Hello, bacho. So let's see the question. And the question says that a long coaxial cable shown in cross section in the drawing is made using two conductors that share a common center axis, level C. So the conductors are separated by an electrically insulating material that is also used as the outer cover of the cable. So the current in the inner conductor is 2 ampere directed into the base, and that in the outer conductor is 2.5 ampere directed out of the base. So the distance from point C to point A is 0.0015 meter, and the distance from C to B is 0.0030 meter. The radii of A and B of the conductors are 6 multiplied by 10 to the power minus 4 meter and 1.9 multiplied by 10 to the power minus 3 meter respectively. So what is the magnitude and direction of the magnetic field at point A? We have to find out. So here 4 options are given. Out of the given 4 options, which one is correct? We need to find out. So now let's see the answer. So first हम लोग यहाँ पे देखते हैं कौन सा की कॉन्सेप्ट यूज होगा. तो यहाँ से हम लोग बोल सकते हैं, यहाँ पे हम लोग की कॉन्सेप्ट यूज करेंगे एम्पियर्स सर्किटल law. So according to Ampere's circuitous law, we can written as equation. It is closed integral magnetic field multiplied by dl equals to mu naught multiplied by I. So here mu naught is the magnetic constant, I is the current, and B is the magnetic field. And here current is inside the loop. So now in the figure, in the inner loop, like this is magnetic field, tangentially acting magnetic field. So here it is also magnetic field acting is tangentially. So from here we can written as, means this is suppose our loop C1. This is C1 loop, and here magnetic field also acting tangentially. So this is magnetic field B. At point magnetic field also act tangentially. This is B. At point also it is act tangentially, and this is B. So for loop C1 हम लोग लिख सकते हैं cyclic integral for C1 B dot dl equals to mu naught multiplied by I1. So फर्दर सॉल्व करने के बाद मीन्स यहाँ से राइट हैंडेड थंब रूल्स यूज करके हम लोग बोल सकते हैं डायरेक्शन ऑफ बी इन shown in the figure that is clockwise and tangentially. So the angle between dl and b vector is 0. तो यहाँ से हम लोग लिख सकते हैं यहाँ पे since using right hand thumb rule we can say that the direction of magnetic field B is clockwise and it is acting tangentially. तो यहाँ से फर्दर हम लोग बोल सकते हैं एंगल between dl and magnetic field B is 0. तो यहाँ से हम लोग लिख सकते हैं for loop C1 close integral C1 multiplied by B dot dl equals to mu naught I1. So फर्दर सॉल्व करने के बाद हम लोग को यहाँ से मिलेगा इंटीग्रेशन सॉल्व करने के बाद B dot 2 pi r, since the value of dl is here you can take as inside the loop, so here dl equals to 2 pi r, which is equal to we can take as mu naught multiplied by I1. So यहाँ से हम लोग को मैग्नेटिक फील्ड B equals to मिलेगा mu naught I1 divided by 2 pi r. So the value of mu naught is 4 pi multiplied by 10 to the power minus 7 multiplied by the value of current I1 is given in the question, which is 2 ampere, divided by 2 pi multiplied by the value of distance at point A to point C. It is given 0.0015 0.0015 मीटर। तो यहाँ से फर्दर सॉल्व करने के बाद हम लोगों को मैग्नेटिक फील्ड B इक्वल्स टू मिलेगा 2.667 मल्टीप्लाइड बाय 10⁻⁻4 टेस्ला, which is approximately equals to 2.7 मल्टीप्लाइड बाय 10⁻⁻4 टेस्ला। सो यहाँ से हम लोग बोल सकते हैं हम लोगों का करेक्ट आंसर है ऑप्शन डी। सो फ्रॉम हियर वी कैन टेन एज ऑप्शन डी इज करेक्ट। सो होप यू अंडरस्टूड इट वेल। बेस्ट ऑफ लक। थैंक यू।